Hello everyone, and welcome back. This is gonna be the second chapter of the tutorial, or the second part. Uh, what we're gonna do now is we're gonna take what we already learned and add some new features to it, new stuff. So what we're gonna do now is we're gonna build something that needs a clock, and we're gonna mess around with something else with something called a logic vector. So let's add a new source. So I'm just gonna add one more VHDL model, and I'm gonna call this one counter because I'm gonna build a counter with it. So it's gonna have two things here. So clock, gonna have a reset. I'm gonna talk about that a bit, and then it's gonna have a count, and then the count is gonna be an output. Okay, we're gonna mention this later, but so these are our three things. I'm gonna finish and voila, I have my initial code. So this is not the whole thing, but we're gonna mess around with it. So what is this gonna be? I'm gonna build the counter, which is gonna just keep on adding up to the maximum amount of bits. So we will have 4 bits. It's gonna be a 4-bit counter. So let me just add this as a comment. So this is gonna be a 4-bit counter. Just for myself, if like in case I try to read this not at a time and I didn't finish writing all of that stuff, just this small comment is gonna help me. So it's gonna be 4 bits. So it's gonna take an input, which is gonna be my clock. So it's gonna have, depending on the clock, it's gonna increase my count, and eventually we have a reset in order to like actually set the input to zeros if I want to, and then it's gonna be the count. The problem here is, as we already figured out, standard logic is gonna be a single bit input or a single bit output. My counter is gonna be 4-bit. So how can I actually in VHDL make a 4-bit output? So this is gonna be very similar to this. It's just gonna be standard underscore logic underscore vector. It's gonna be all uppercase. And then I'm gonna mention how many bits I have. So this is gonna be something like this. So 8 down to whatever. Let's say 0. So this means I'm gonna have uh, bits from 0 to 8. So that's 9 bits. I'm not going to do this. I'm going to actually build 4 bits. So this is going to be 3 down to 0. So the most significant bit is going to be 3, and the least significant bit is going to be 0. So this is going to be count 0, count 1, count 2, count 3. Okay, so this is the way I just made my my output. So the next thing is going to be is I need a way to actually like have this work whenever a clock is changing basically. So I'm gonna go here into my architecture, and like we did before, I'm gonna make a process. So this process is gonna be based on 2 things: my clock and my reset. So this is something here that you will notice a lot of programmers keep doing whenever they already made a variable or a byte or whatever. They're gonna keep on like copying it instead of writing it down. This is just a force of habit because we tend to make mistakes as we go along. So I'm gonna make begin and end this process. And this is the mistakes that I did in the last video, so I'm just like trying not to have that happen again. Okay, so this is gonna be my work. So what I wanna do is, if my clock comes and my reset is not 1, I wanna increase the counter by 1. So if my reset is 1 actually, so if reset is equal to 1, and you will notice I didn't mention this before, but equal in VHDL is just 1 equals instead of 2 like any programming language, because the assign operator in here is actually like smaller than and then equals. That's why. Okay, so when the reset is 1, I want to be able to like set the counter to 0. What usually is being done is usually we would have something in the middle to have the value saved as. So it's almost like we would say this is a variable. So this variable is called signal, and we are gonna give it any name. So I'm gonna call it a count underscore value. So this is the value of the counter now, and I will do 2 points. This is gonna be how I mention what type of vector it is or what type of value it is. I can have it as standard logic, so 1 bit, or I can have it something like standard logic vector. I'm gonna save it as 4 bit, so it is the same value as count, or like the same number of bits as the count. And then I'm gonna add something like this. So what is this? I am actually giving it value at the start. And then you notice that this is actually double quotation. Let me just okay, this is just to make sure that this is saved correctly into my count value. So this is gonna be saving 000 at the start. So this is just its initialization. So if this happens and I'm actually in the if loop, I'm gonna have the count value as the same value at the start, which is zeros. Okay, so this is just resetting the value. So in case, and this is something we didn't do, if I want to do else if here, it's gonna be else if. No E in this one. So this means that if this is not the case, so if reset is 0, we are gonna work with the other thing. So this is the different thing. I want my clock input to only affect me if I'm on the rising edge. Why is that? Because I don't want to keep changing the values if the clock is on the higher output. So this is gonna be rising edge. So as you can see, it already changed the color, and that's because it is a built-in uh, function clock. Then count. Oh yeah, keep copying it because it's gonna be easier. It's gonna be equal to count value plus 1, and this is the reason why we actually didn't type right away into count, because sometimes when I do this, it doesn't work correctly. So this is just from experience. Sometimes you will try it out and it's gonna be better than me, so it's fine. But yeah, and don't forget to end your f. So end f, and now our complete process block is completed. But there's something missing. We actually didn't assign anything to the output. So remember this. You always need to assign the value at the end. So count, I need to assign in something. I'm going to assign it the value of this variable, this signal. So what will happen is each time I go into the process, clock or reset changed. If reset changes from 0 to 1, I'm gonna reset the value of count value and it is gonna be a 0. If it is not, if clock is on a rising edge, then I'm gonna add 1 bit, or like increase my count value by 1. So it will keep on changing up until it goes to 4, which is, no wait, was it the time to say? Yes, it's 3 bits. So it's gonna keep on increasing until it's 7, because that's the maximum number you can have. Yeah, it is 7. Yeah. So yeah, so we are gonna actually simulate this, but just to make sure that everything is correct. Also, you have to make sure that you are when you are uh, uh, working on your synthesis, you're gonna have to make sure that you have actually selected the correct thing. So I'm in synthesis here. I'm gonna go over here. Wait up. Okay, this is a bit different. You can see that the synthesis over here is just fine for the AND gate, but for some reason the counter is not appearing. Uh, Okay, then I fixed the issue, but it was not an issue, it was just me forgetting. So the process is here, the synthesized process is only working with something called the top module. This is something that if you go into VHDL a bit more and about combining which modules control which, basically if you want to like build a PC inside of it, or like not a PC, let's say that you want to build a small computer of BGA. What you will do is set one module as the top module, that is the one that is taking from all the other smaller entities inside of the if we design and you will synthesize this one. So in my case, I have an AND gate and the counter. So there's no top module, it's just two of them. So if I want to synthesize counter, I will actually need to set it as top module, even though there's no interaction between each of them, just how the software would work. If I go to this and synthesize, this should work just fine. Unless I made some mistakes or something. Okay, it is working just fine. So I'm gonna add a new source. It's gonna be my test bench. Let's call this one test C because I already had two tests here. And here I'm gonna select counter as my source. So now this one I actually need a single clock here. I don't need the combinatorial input. So because I select the single clock here, I can actually like select how much I want to work and stuff like that. But for now, just finish, and then we have my inputs. So just the signal of clock, and then if we look at the output, the count, you can see that the C bits are represented over here or by a single vector. So I'm gonna go at the start. I'm gonna set the reset by 1, and then I'm gonna stop, and then let's see what happens after that. So let's go to process, and then I'm sorry, to behavior simulation. Select the counter, and then I'm gonna simulate the behavior. Let's see what happens. Okay, it is simulating the other guys for some reason. Okay, let's try again, because I probably didn't select the correct thing, so I'm gonna oh yeah, probably. Yes, simulate behavior model for TCI. I probably did the tricky one. Yeah, well, okay, and yeah. So as you can see, my outputs keep on changing. So because at the start there was a reset, so it was at 0, then each rising clock I'm increasing my count by 1 bit, 1 bit, 1 bit, and then it keeps on changing. So if I set out my output to the correct length, it should actually show up. So let's actually do that. Just again, properties. No, I keep forgetting, so I'm just gonna make a new one instead because I generally keep forgetting how to do this. Like how to test this after it is actually done. So test 4, next, counter, yes, finish, and then here I'm gonna set out it's gonna be rising edge, and then the initial length of the test bench. Let's have it at, let's say, I don't want it twice. Let's say 4,000 nanoseconds. Finish. Then I can have multiple times like this. I'm gonna set reset by 1 only for the first bit, and then it's gonna be 0 at rest. Okay, so let's go to processes. Was TC selected? Sorry, was it TC? No, I think I added T4, right? Okay, something is amiss here. Okay, 4, let's see, it's fine. It's not showing up. Okay, so after I finish that, I actually T4 actually shows up. So this is just a problem with the software. I'm gonna just turn T4. I'm not sure why it didn't show up at this side, but yeah. If you look at this, it keeps on increasing. Oh, it was 4 bits, not 3 bits. Oh, my brain just was fried. So the maximum is actually not 7, it's actually 15. I forgot, I thought we were working with the 3-bit example. My bad. So yeah, it goes up until 15, and after that, because all of the bits has already reached the maximum, and you add 1, so it causes an overflow. So it goes back to 0, and then it starts again. So this is the example that we wanted to show you about how to use the clock with the rising edge with if statements. Okay, so what else are we gonna build? We're gonna build something very interesting. We're gonna do multiple sources, and we're gonna combine them into one big thing. So I'm gonna make a new source, and this one is gonna be also VHDL, because this is all about VHDL today. And I'm gonna make a NOT gate actually. So this is gonna be something very simple, but I'm gonna actually use it with something else. So let's build in and NOT gate actually. So let me look at this. Let my skip because I don't want to mess this up. Okay, so I wanted to build the node gate, wanted to build this one. Okay, then let us try to actually build this entity. We didn't specify anything, so it's gonna be empty first. So what I'm gonna do is gonna build the pods first. So pod, and this is something that I keep actually mistaking myself. So watch out for that. So usually when you finish the pod, the last one, um, you keep doing this. So I'm gonna have two of them. So one is input. It's gonna be standard logic. So 1 and 0. The output is gonna be let's say it is x, for example. It's gonna be an output. So let's have it as y actually, like the previous examples that I actually made before recording this. So I just don't make another mistake while recording. Okay, so I have set this as this. So this is a mistake that I actually keep on doing. Let me just zoom out for you. Zoom in. Don't you have to not actually have a semicolon at the last one of your bots. So the semicolon is just the separation between each one of them, and on the last one you have to not have any of these. So it's kind of weird, but yeah, well, it's fine. But yeah, this is gonna be just a simple not gate. So I'm just gonna say y is assigned not of a. So whatever is gonna go into a, y is gonna be the something different from that. So this doesn't actually need anything. I'm just gonna make sure go back to my synthesis, and since because this is just was built, I'm not sure why it is not showing. It's weird. Yeah, let's go to process and check syntax. Sure. Uh, why is my not not there? It's weird. Okay. Maybe it needs something like this. Maybe. Go back to synthesis. It's not a being for some reason. Okay, so something is amiss here, and I'm not sure what is. So I'm just gonna copy my code, and then like this window, close this window. I'm just gonna add a new source, and then let's just let's call it the same, I guess. So this is not. Let's call delete. Next. Yes, I want to replace it because it's not a being in this. Maybe it's this problem. I'm just gonna have an A and a Y. So this, as I told you before, because this is an old software, these kind of problems can arise at any time like this. So for some reason it's actually not showing up at all in my design. And this is weird. I have no idea why it's happening. So in this case, because I'm just showing this, I'm just gonna make a new project. In your case, you will not have to have multiple uh, behavioral models like this, like I'm doing, but so don't worry about it. Just this errors that would happen on a larger scale. That's why there's a new version of this software. So video design. Next, I'm just making a new project just for that sake because these things do happen with me a lot of the times. So I'm just gonna make my new source. It's gonna be my node underscore gate, and it's gonna be a VHDL model, and then A and Y, and then Y is gonna be my output. Finish. Now it's a being, so everything is working correctly this time. It's probably something to do with the settings that I messed with, so maybe I did some mistakes and that's why it's not showing on here. Doesn't really matter. The important part is we can do this now, and I can synthesize, turning. Yep, it is working just fine. Okay, so this is not what I wanted to show you because this is already something that you already covered previously. What I'm gonna do is I'm actually gonna make something a bit more complicated. So I'm gonna make a gate that is using both not and and. That's why I wanted to make it in the previous one, but it didn't work for me. So I'm just gonna project new source, and I'm gonna call it a top module for this example. So it's just gonna be combining the both of them. It's gonna be VHDL module, and it's gonna have three things: input one, that's my input, and then input two, and then output. It's gonna be my output. Don't forget to change it. Then finish. It is done, but I'm gonna actually make it my top module because it's gonna combine multiple things, and I'm gonna actually need it to start the stuff. So what is this? So this is the thing that I was talking about. So first of all, we don't need these comments. This is fine. Just gonna delete them. But actually, I'm just gonna delete this. Then I'm gonna do something we didn't do before. The ones who showed up in the lab last week probably have seen me do this. I can actually just make another module inside of the same file. So what I'm gonna do is I'm just gonna make AND gate again. So this is gonna be my let's make very distinct names. So A, actually just go with the same A, B, and Y, and over here the output Y is gonna be set to the value of A and B, and don't forget to change the name over here. So with this I actually just made a new AND gate, and if you look at here it actually made the AND gate. It's part of this design, but now I can actually use it in this top module. So this is a part that is new. We're gonna use the thing that we already showed previously in the VHDL test bench, which is the component. So what am I gonna do here exactly? So I'm gonna go here and I'm gonna make something called instance. So what I'm gonna do over here is okay then, so let us change that again. This is gonna be my AND gate, and my input is gonna be my A, and another input is gonna be my B, the input, and then this Y, and the reason there's a continuity error in this video is because I forgot to do this and I was trying to fix it. Yeah, this actually happens a lot, so watch out for that. And in this I'm just gonna say Y is assigned to A and B. So now my AND gate has been actually updated and it should be working just fine. But it's, as you can see, it's in the top module file. So yeah. Okay, so here I'm actually gonna use what I already built. Let me just look at my script over here and my code that I already wrote before, just to make sure that I'm writing the correct code. So yeah, what I'm gonna do now is something called importing. Basically, what I'm gonna happen is I'm gonna get the AND gate that I already built into the architecture behavior. So what I'm gonna do is I'm gonna build inside of this top module, I'm gonna build an AND gate. So I'm gonna have an AND, and again the output of it is gonna go into a NOT, and then that's the output that I want at the end. So what we are gonna do is we're gonna import the AND gate. So to import the AND gate, before the begin block we have here, we're gonna say component, and this is the first part. The second part is just gonna be copying all of this. So if I do this correctly, so I forgot the very important part here, which is the name. So I'm gonna say component and gate, and then copy all of this. I don't need the is, and I don't need the AND gate over here because it's already made. So component. So what this means is I made the AND gate that I already made over here available inside of my top module. So I want to do the same for my NOT gate, but before that we're gonna have to do some things. The first thing that I want to do is I'm gonna check on this here quickly. So yeah, oh yeah, okay. So inside of here, if I want to build an AND gate or like make an instance of it, I'm just gonna do this A0, for example, or like AND 0. So this is my and I'm just gonna say uh, uh, two dots like this, and if I have it like this, and then say AND gate, this will mean that this is gonna be my AND gate that I just made, so under the name of AND 0. So I can actually just make multiple of these if I wish to. So AND 0 and 0 and 0, and then just need to actually change the names, but I'm not gonna do that now. What I'm gonna interested doing is I want the inputs of this top module to go into the inputs of my AND gate. So if I go to paint, for example, we can actually have an example of this. So let's actually zoom in a bit. Oh yeah. So I want to build inside of this top module. So this is my top module. It's actually pretty bad. Let me just make this better. So I'm just gonna make this a lot bigger like this, and then I'm just gonna zoom in. Okay, so my top module is gonna be like this, and I need a tablet because this is not gonna be very easy. Anyways, so in my top module over here, I have two inputs, input 1 and 2. So in 1, in 2, and then at the end of the other side is gonna be out. And I wanted to build inside of this an AND gate. So an AND gate is an and then a NOT gate, right? And then I want the output over here, the input over here, and over here, and over here. So I want these two devices to work like I already designed them, but I just need to connect the wires to each other. So connecting the wires to each other is called port mapping. So I want this one to be connected to A, this one connected to B, and this one, the output is going to be connected to something that is going to be connected to my NOT gate. So I can call this anything. Let's call this one X, for example. And then I want X to be the input for my uh, this value over here for the NOT gate, which is Y, and then the output from Y is gonna be connected to my output on the outside. So I need some kind of wire in the middle to connect these two together. So this wire is gonna be my variable. So it may sound very weird, but this is the way we already talked about this last time about the signals. So signals I usually just say they are variables, but they are actually just wires, uh, like connecting the data with each other. So just say signal is X, and it is a standard logic. So it's gonna be just 1 or 0. It's not gonna be a vector. And then I'm gonna use this to like, connect the two of them together. So my AND gate, I'm gonna do the port map for it. So port map, this means that I'm gonna say which parts are connected to which parts. Okay, so for my port map over here, it's gonna be like this. So this is gonna be very important. The ones on the left side are gonna always be the ports inside of my AND gate. And whatever is on the right side is whatever is connected to them. It doesn't like depend on direction, just connecting wires together. So A is connected as we told before to input 1. Let me make sure that it is copied correctly. Semicolon. B of the AND gate is connected to input 2, and then my Y is not connected to the output, it's not going to be connected to my wire, which is X. And remember, we don't add the semicolon inside of here because this is the last one. We're going to have it on the end. And because of this, I just made an AND inside of my top module. So the next thing is going to be, which is going to be the other part here, which I want to have this NOT gate that it is not in this file in here. Do I actually need to do the component part? No, actually, I just need to make one object of it right away. So what is happening is going to be node 0, same way that I did it before with the and here I'm going to say that this is based on the node gate that it is here. So I'm just going to say entity work dot not underscore gate, and this is gonna do the same thing that I did before. So it's gonna just import it into my side over here. So this is something that you will probably never do, like have the node gate in another file and just import it into here. But in case that you ever wanted to do that, that's a way to do it. So I have two things in my node gate, which is my A and Y. So A then Y. So what do I have them connected to? I actually forgot, so I will come back. So my A is connected to the Y inside here, which is X, and my Y is connected to the output. So let me connect this to X, and then the Y is going to be connected to my output. So where's output? There's output, and this should be sufficient to work actually. So let's make sure that we didn't do any mistakes. So top module is selected as the top module here, and then we just turn synthesize, and hopefully it works just fine. If there's any mistakes, it will appear in this process. Let's just make sure. Okay, so we do have errors. I had okay, so let's see what errors we have. So it says pass error unexpected semicolon. So that means that I wrote something. Oh yeah. So in the board map, we don't actually have semicolons in between them. We actually have commas. So this is something guys that I actually keep forgetting. So yeah, we'll make mistakes. So let's try again, and hopefully it works this time. Okay, and we have some warnings, but other than that, this is working just fine. So let's make sure that it is actually working. And you can actually see that inside of the top module, we have made an AND 0 and a not 0, because and this is how we did it with the synthesize. So whenever you synthesize something, if there's any gates inside that you actually need to be made, it will actually make them. So the next part is we're gonna add the test bench. Let's call it test 1 because this is the first test we have here, and we're gonna select the top module because this is the one that we actually wanna test. Okay, so we don't have any clocks on this. We're gonna have it on combinatorial like we did before, and I'm gonna just test out the outputs. So I'm gonna do the 1 0 0 1 and 1 1 0 0 1 0 1 then 1 1 then 0. The reason I did this is the reason like we did it before, just to make sure that the output shows up at the end. Okay, let's go to behavioral test 1, then simulate behavioral model. Hopefully it works just fine. Okay, so do we have this correctly? Yes, because this is an AND gate, it's always producing 1 until you have 1 and 1. Everything else is producing 1, so this is working just fine. And with this is the end of the tutorial. I hope this gives you insight of how to do VHDL, and it gives you like an like a starting step for whatever other things that you need to do with VHDL. If you have any problems or any questions, please go ahead and ask me whenever you will have. I will be presenting you with like announcing for you my office hours if you need any help with your code or with your assignments. Other than that, I hope you have a grand week and see you later.